Today we will continue our discussion about finding area of two-dimensional figures. In section 7-2, the focus will be on solving triangle area problems. Interestingly, finding the area of a triangle is very similar to finding the area of a parallelogram or rhombus. The three examples at the top under the key concept illustrate this point. In all three examples, the rhombus, the rectangle, and the parallelogram, a diagonal line has been drawn from opposite vertices, cutting the figures in half. The result is two congruent triangles. Remember that the formula for the area of a parallelogram or rhombus is A equals base times height. So let's write that note here. So area of a parallelogram or rhombus, a rhombus is a special type of parallelogram, is A equals base times height. And we practiced that over the last 2 days. The area formula of a rectangle is area equals length times width. And remember that the B in this formula for base and the L for length in the area of a rectangle are interchangeable, and so are that the H and the W, depending on which figure you're talking about. So the area of a triangle formed by those diagonal lines will be half the area of a parallelogram, rhombus, or rectangle. Now you can see the formula below each figure, and this shows the area formula for the shaded triangles. So you'll see underneath the figure, the shaded area is half the area of the rhombus, the rectangle, or the parallelogram. So A equals 1/2 times the base times the height. Below those formulas, it shows you the steps, okay? So the 1/2 is given, so you just bring that down as you plug in. Just focus that a little bit better. As you plug numbers into your formula, okay? So the numbers that are given in the formula you bring down. And then this B here, the base, we're replacing with the 12, okay? So something important to know about the base of the triangle. The base is the horizontal line, okay, that runs along where the right angle is. So if we turned this, okay, so now it would be horizontal, okay, to that right angle. So this is the base right here, which is the 12. And typically in a diagram like this, the dashed line is going to represent the height. And the height is 6, okay? Now the height is the line that's formed when you drop this vertice here, the top vertice, down perpendicular to the base. So it's really the distance from the top vertice to the base of the triangle. So then you just multiply across. Sometimes you can do this in your head. you would start 1/2 times 6, and I would get 6, and then I would multiply that by 6 to get the 36 centimeters squared. And remember, this is a two-dimensional object. There's only two dimensions, a base and a height, so that's why we have that superscripted 2 here to represent squared. Okay, now moving on to the middle example. This diagonal was drawn in a rectangle, and what we get are two triangles that are right triangles. Same formula, because the shaded area that's formed from that diagonal is 1/2 the area of the rectangle. So you would use, instead of area equals base times height, or you could say length times width, you would need to take half of that. So since we're given the 1/2, we just bring that down. And now we're going to look for the measurement for the base, which is going to be this 15. Now remember that here you would have your right angle. This line is horizontal to that angle. So we plug in the 15, and then the height would be the perpendicular line, okay, that's dropped here, perpendicular to the base. So that would be the 8. Okay, now what I would do here, if I was trying to do this in my head, I would take 1/2 of 8, because 8 is even, so half of 8 is 4, and 4 times 15 is 60. If you're plugging this into the calculator, of course, you'd want to use that ABC key on the school calculator, that TI-30 calculator that we've been talking about. You put that in first, multiply by 15, and then multiply by 8. You just work from left to right. And then in the last example here at the top, here we have a parallelogram and our diagonal line. It forms two obtuse triangles because this angle here in the center of each triangle is an obtuse angle. Using the formula 1/2 base times height, we're going to just bring the 1/2 down because that number is given. The base here would be the 8, because when we drop this vertice, the height is actually sort of outside of the triangle, okay? And here's the right angle, and it runs horizontal, okay, to the base. So that would be your 8. And then the height here by this dashed line is that perpendicular line to the base. You get the 5 2/10. So again, if you could do this in your head, you would want to take half of the even number. So that would be 4. So I'm multiplying this first. And then 4 times 5 2/10 would give you the 20 8/10 centimeters squared. You can't do that in your head using a calculator. You could also use 0.5 or use that ABC key to set up your fraction, times 8 times 5 2/10. Okay, next section is the do you understand? And question number 1 is always the essential question. How can you find the area of a triangle? Please take a moment and write that down. I do have a little glare. I'm going to try to zoom in a little bit as you take a few moments to write this down. Let me turn off the light. That's going to help for that one. If you need another moment, you can just pause the video, finish your writing, and then just pick up when you're finished. The answer states that the area of the triangle with base B and height h is equal to half the area of the parallelogram with base B and height h. The area formula for a parallelogram is A equals B times H. So the formula for area of a triangle is area equals 1/2 base times height. And that's really what we went over at the top under the key concept. Question number 2. If you cut a rectangle into 2 identical triangles, what type of triangles will they be? So if you go to the top under the key concept, look at the middle figure, the rectangle. What type of triangles are formed? You get 2 right triangles when you use a diagonal line to split a rectangle into 2 triangles. And that's because that middle angle is a right angle, and a right angle has a measurement of 90 degrees. Number 3, construct arguments. In example 1, at the top under the key concept, if the other diagonal were used to divide the parallelogram into 2 triangles, would the area of each of these triangles be half the area of the parallelogram? And explain. So all that is saying is, if instead of putting the diagonal here, if we put the diagonal here, okay, across those opposite vertices. So the answer would obviously be yes. These 2 triangles would have the same base and the same height as the 2 triangles in the example. And since you're just multiplying those 2 numbers, there are only 2 numbers given, you would get the same answer. Of course, we would have to also take that number and divide by 2 or multiply by 1/2. Okay, we're going to look at a couple examples. I'm going to do number 4 and 5 with you and give you a few moments to try number 6 on your own. Okay, question number 4. You have a right triangle. We know that because this middle angle here is a right 90-degree angle. Since it's a triangle, it's going to be half of the formula for the area of like this would be a rectangle. So you could use length times width or base times height. Let me turn this light back on. Okay. So the base is going to be this 4 because it runs horizontal here to that angle. So I'll plug in a 4. I'm using a parenthesis to keep my numbers separated. And then the height would be the line that's dropped down here from this top vertice, and it runs perpendicular to that base. Okay, and then the last step is just multiplying across. You always want to take half of an even number if you are doing it in your head. So it's nice that the even number is next to it. So you get 2, and then 2 times 2 is 4. And don't forget your units of measure. So it's in feet, and it's squared since there's only 2 dimensions. Okay, question number 5. Again, it's a triangle, and a triangle will be half the area of, and then this would be, if you extended this, if you put the triangle into, doubled this triangle, kind of reflected it on the other side, because remember this is half of a parallelogram. Okay, you would get the parallelogram. So it would be half the area of a parallelogram, which is base times height. We're going to bring down that 1/2. Now, you have to know where the height is. So we're going to use this top vertex. We're going to drop that line down. It's going to end up being on the outside of the triangle. And then so your right angle ends up here. And so this would be the base, because the base is going to run horizontal to that line. Okay, so the base is the 4 2/10. And then the height would be this dashed line here. It's the line that's perpendicular to the base. Okay, now half of 4.2 is 2.1. And 2.1 times 3.5 is not something that's necessarily real easy to do in your head. So this will definitely be one that you need a calculator for. So you're going to use that ABC key if you're using the same calculator that I'm using in class, or you could convert that to the decimal 0.5 times 4.2 times 3.5, and you're going to get 7 3/35 inches squared. Take a moment and please do question number 6 on your own. When working with formulas, get in the practice of always writing your formula first. It not only helps you to memorize that formula, but it keeps your work very neat and orderly. So we're going to bring down the 1/2. Now the base would be here. It's the 5 because it runs parallel with this angle here. So the 5 would go where the B is in the formula. And then the height would be from this top vertex. We drop this line perpendicular to that base, and the distance between that vertex and the base is 6.5. And now we would multiply across. 1/2 times 5 is 2.5, and 2.5 times 6.5 is 16 25 centimeters squared. This concludes the lesson on 7-2, solving triangle area problems. Have a great day.